We continue studying polynomial and rational functions by reviewing quadratic functions. So the graph of a quadratic function is a parabola. It has an extreme point called the vertex, which on the graph is located right here. So if the parabola opens upwards, as this example shows, the vertex is going to be a minimum. If, on the other hand, opens downwards, so imagine flipping this graph upside down, then the vertex becomes a maximum. So this vertical line that passes through the vertex is called the axis of symmetry. So called because the parabola is perfectly symmetrical about this axis. The general form of a quadratic equation is f of x equals ax squared plus bx plus c, where a, b, and c are all real numbers with a not equal to 0. Now, if a was 0, then this would just simply be linear, which is why we restrict a to not be 0. If a is greater than 0, so that is if a is positive, the parabola will open upwards. If a is negative, the parabola is going to open downwards. So everyone should be familiar with quadratic formula. I am going to derive it right now. So let's suppose we wish to solve the equation ax squared plus bx plus c is equal to 0. So we can do this by completing the square. So the first thing we want to do to complete the square is make the coefficient of the x squared term 1. So we divide everything in the equation by a. So that'll now give us x squared plus b over ax plus c over a is equal to 0. Now let's move the constant to the other side. So we'll have x squared plus b over ax is equal to negative c over a. So now we complete the square. We do this by taking half of the coefficient of x and then squaring it. And then we'll add it to both sides of the equation. So we have x squared b over ax plus the quantity of b over 2a squared is equal to the quantity of b over 2a squared minus c over a. And by actually distributing the square through and subtracting fractions by finding the least common denominator, this will simplify to b squared minus 4ac over 4a squared. Now the point of completing the square was we can now write this as a perfect square binomial. Specifically, it's x plus b over 2a all squared. If we now take the square root of both sides, we'll have x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac all over 2a. Remember that when you take the square root, it's a plus or a minus. Now we can just subtract both sides by by b over 2a, and we'll get x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Now these two fractions already have a common denominator, and so this gives us negative b plus or minus the square root of b squared minus 4ac all over 2a, and you should recognize this as quadratic formula. And so the solution to the equation ax squared plus bx plus c equals 0 is given by the quadratic formula, which we just derived. So we can now find the equation for the axis of symmetry. The value halfway between the x-intercepts will give us the axis of symmetry. So the two x-intercepts are where the function is equal to 0, which we just said is given by the quadratic formula. So the one is negative b minus the square root of b minus 4ac all over 2a. The second one is negative b plus the square root of b squared minus 4ac all over 2a. So the point between them is you take their sum and divide by 2. Well, these square roots are going to cancel out. We'll be left with negative 2b over 2a, which is negative b over a all over 2. And so that negative b over 2a. And so that is our equation for the axis of symmetry. Now, a quadratic function also has a standard form. And its standard form is given as f of x equals a times the quantity of x minus h squared plus k, where the point hk is the vertex of the parabola. Now, this form is useful if we wish to sketch the graph of the quadratic function. What we're going to do is we're now going to compare the standard form and general form and see if we can glean any useful information out of it. So comparing them, just set them equal to each other. Now, if we actually do this x minus h squared out, we'll get a times x squared minus 2xh plus h squared plus k is equal to the general form, ax squared plus bx plus c. Now distribute that a through. Ax squared minus 2axh plus ah squared plus k is equal to ax squared plus bx plus c. So let's compare the coefficients of the x terms. So that means that negative 2ah is equal to b. And so h would have to equal negative b over 2a. Now this makes sense because the axis of symmetry passes through the vertex, and it said that x was equal to negative b over 2a. So since h is the x coordinate of the vertex, it does make sense that it should be negative b over 2a. Now if we compare the constants, we'll have ah squared plus k is equal to c. We wish to solve for k, so we have k is equal to c minus ah squared, but we just found what h was. So this is c minus a times the quantity negative b over 2a squared. Now this squared becomes b squared over 4a squared. So if you now distribute that a through, you get c minus b squared over 4a. So this is k, this is the y coordinate of the vertex. So the quadratic function, ax squared plus bx plus c, has the vertex at negative b over 2a, comma, c minus b squared over 4a. So here we're given a graph of a quadratic function, and we wish to write it in its general form. Right? So to do this, the first thing we have to do is we have to look at the vertex. Well, if we look, vertex is located right here. That's located at the point negative 2, negative 3. So hk is the point negative 2, negative 3. So the general form, the standard form, remember, is f of x equals a times x minus h squared plus k. Let me just double check that. Plus k, so minus 3, is equal, no equals, where this a is a value that we need to find. So let's find it now. We can do that by looking at f of 0. So when x is 0, we come over here, back to the graph. F of 0 is along the y-axis. Oh, so it's minus 1. So this is minus 1, but it has to be a times 0 plus 2 squared minus 3. So this becomes 4a minus 3. So if we add 3, we get 2 is equal to 4a. Now divide by 4, and we find that a is 1/2. So f of x is 1/2 times x plus 2 squared minus 3. Now it's just algebra, so we have 1/2. X plus 2 squared expands out to x squared plus 4x plus 4. Distribute that 1/2 through. So we have 1/2 x squared plus 2x plus 2 minus 3. And so we find the general form is f of x equals 1/2 x squared plus 2x minus 1. So now let's sketch the graph of 2x squared minus 6x plus 7. So let's first note that a is 2, b is negative 6, and c is 7. So to find h, remember it is negative b over 2a, so we get negative 6 over 2 times 2. This is 6 over 4, which is 3/2. K, remember, is given as c minus b squared over 4a. So c is 7, so we have 7 minus b squared is 36 over 4a, so 4 times 2. So let me just write this as 6 squared for now. So it's 7 minus 36 over 8, which is 7 minus 9/2. So this becomes 14 minus 9, which is 5. So it's 5/2. So the vertex is located at the point 3/2, 5/2. And we also know that a is greater than 0, right, because a is 2. So it opens upwards. Now, since it's opening upwards and the vertex is already above the x-axis, there will be no x-intercepts. So if we go ahead and sketch our graph, let's say that's our x, that's our y-axis. 1, 2, 3, 4. Let's just do 4 ticks. So 3/2, 5/2. So 3/2 is 1/2. That's right here. 5/2 is 2/2. So that's right here. So here's our vertex right there. Now let's see if it crosses the y-axis and where. So we want f of 0, which is 7. So it's going to cross somewhere way up here. So it's going to look something like this. Oops, that's too steep. And so that is a good representation of this parabola. So the domain and range. The domain is the set of all real numbers. The range depends on the value of a. If a is greater than 0, the range will be k to infinity, including k. If a is less than 0, it'll be negative infinity to k, where again k is included. So the unit price of an item affects its supply and demand. That is, if the unit price goes up, the demand for the item will usually decrease. As an example, a local newspaper currently has 84,000 subscribers at a quarterly charge of $30. Market research has suggested that if the owners raised the price to $32, they would lose 5,000 subscribers. Assuming that subscriptions are linearly related to the price, what price should the newspaper charge for a quarterly subscription to maximize their revenue? So we're looking for the price to charge to maximize revenue. So the first thing we want to do is, since we're assuming subscriptions are linearly related to the price, let's find the slope. So the slope is going to be then the difference in subscribers over the change in the cost. So the difference in subscribers, they said, would be a loss of 5,000, so that would be negative 5,000 over change in price. That was an increase from 30 to 32, so that's an increase of 2. So the slope is negative 2,500. So if S is going to be the number of subscribers, P will be the quarterly charge. We can write this as S minus 84,000 subscribers is equal to negative 2,500 times P minus $30. Where here I'm taking just a single point, so I'm taking the 84,000 starting subscribers and the starting quarterly charge of $30. So this means, distribute that negative 2,500 through, we get negative 2,500p plus 75,000. If we add this 84,000 to both sides, we wind up with S is equal to negative 2,500p plus 159,000. So this is what represents or relates the number of subscribers to the price being charged. However, we wanted to maximize revenue. Well, revenue is the unit price times the number bought. So in this case, it is the price times the number of subscribers we have. And we just found what S is. S is this down here. So it's P times negative 2,500p plus 159,000. So we get negative 2,500p squared plus 159,000 times p. Now we notice that A is negative 2,500, so this parabola is going to open downwards, which means the vertex is a maximum. So we want the p coordinate of vertex. So that would give us h is equal to negative b, which is 159,000, over 2 times a, which is negative 2,500. Okay, so this becomes 159,000 divided by 5,000. So remember, when dividing by factors of 10, we can get rid of 0, so 3 zeros will cancel out the 3 zeros in the denominator. This is 159 over 5. This is approximately 3180. So quarterly charge of $31.80 will maximize the revenue. And so with that, we now will look at how to find intercepts. So x and y intercepts. Well, the y-intercept is easy to find. Remember, the y-intercept is where x is equal to 0. So to find it, we just evaluate f of 0. So this will become 3 times 0 squared plus 5 times 0 minus 2, we get negative 2. So the y-intercept is equal to the point 0, negative 2. Okay? So we found the y-intercept. Now we just have to find the x-intercept. Well, the x-intercept, remember, is where the y is equal to 0. So that is, we want f of x, which is 3x squared plus 5x minus 2 to equal 0. And so we want to solve this. So we could use quadratic formula, but we could check to see if this factors. So combinations of factors of 3 and 2, when subtracted, give 5. Well, we only have 2 factors of 3 and 2 factors of 2. So let's do x and 3x. Well, 6 minus 1 is 5, right? So we want to multiply the 3 by 2, the 1 by 1, and the higher product will take the positive. So it's x plus 2 times 3x minus 1 is equal to 0. Right? So this would mean that x plus 2 is equal to 0, or 3x minus 1 is equal to 0. Which would mean that x is equal to negative 2, or x is equal to a third, right? Add 1, divide by 3. So the two x-intercepts are negative 2, 0, and 1/3, 0. And with that, we conclude our review of quadratics.